And with that, I'm going to let Ken kick it off and take it from here, and I will stick around for a little while, but it's your show, Ken.
Thank you, Brad. And now that Jack and Peter have arrived, I feel like we actually can begin. Schedule today is loose, purposely. I've got some time slots up there, but I can let it slide a little bit. We've got time. We've got extra time in this today. The goal is to have a conversation and to have discussions. And so we have some thought-provoking people that are going to speak, and then we want to have a conversation together. What struck me last year at COFES was when somebody stood up and said, the most significant thing I heard here this year, I heard at DOS. And what they said was, I heard and learned about cradle to cradle. They did not know about C2C. And to me, that was like, okay, that was a win. That's what we're trying to do. And we're going to be speaking more about that today. So one of the goals that I have for all of you is to track key thoughts. What really strikes you? What's new? What's important that needs to be carried to our friends within the larger body of COFES? What are the sticky memes that we want to get out there? Okay. I put myself first on the agenda. That's one of the, I'm in control of the agenda. I can run long if I want to. Sorry about that. But then I get to be out of my own speaking mode, and I'll just sort of help facilitate everybody else through the rest of the day. And I do have a story to tell you. It's been an interesting time over this last year. And I think many of you know that I'm an outdoorsman and a fisherman. I love chasing steelhead with the fly rod. What's that? Cold water fisherman. Wintertime steelhead fly fishing. However, this is summertime on the Deschutes. It's a place I love. I've been fishing it for 40 or 50 years now.
Where is it?
Central Oregon, eastern side of the Cascades, flows off of Mount Hood, flows into the Columbia River. Last summer was a tough summer for me for a couple of reasons. I've been fishing this river, like I say, 40 years. And last summer, for the first time in Oregon, all fishing was shut down at 2 in the afternoon. And that went on for about 8 weeks. And they did that because of heat stress. It had never happened before. And I typically I usually wait till after the kids get off the river. So I wait till after Labor Day, start fishing in September, right after Labor Day. I'm shifting backwards because the timing on the runs is shifting. What's happening in the river is shifting because we've now got glacial melt coming down later and later into the summer. That's, the glaciers on Mount Hood coming down. I went to Yellowstone with my wife. Of course, I didn't want to go. I didn't want to go to Yellowstone. Because it's got all this traffic, all these people in lines. Two things there. One, driving back from Yellowstone to Oregon, the whole Pacific Northwest was just smoke. Most of the summer, it was just smoke hanging in the air because of the forest fires. It really became personal to me with 2 words, 2 books I was reading. Anthropocene. How many of you have heard that? A couple have. The U.S. geophysical scientists have been meeting for the last 3 years to determine if we now have enough physical evidence to rename the geological era that we are in. And they have decided we do, because a space traveler coming to this planet 1 million years from now would be able to look at this time by the record that's left in the crust of the Earth and see that we have shifted into a different epoch because of the amount of radiation that is now on the planet and the amount of plastics that are now in the oceans and the amount of CO2 that's in the atmosphere. We're in a new era. Humans have become a driving force of our planet. That's what Anthropocene means. The other word is a weird word. It was from a philosopher, and it's a hyperobject. It made me think of hypercard and hyper this and hyper that. So I wasn't too sure about that word, but we're object-oriented. I have an object in my hands. I'm looking at an object in front of me. I'm touching an object. As humans, that's what we do. There are different kinds of objects. And I realized, looking at that buffalo in Yellowstone that was looking back at me, that to that buffalo, I was a hyperobject. Because that buffalo didn't know where I came from, didn't understand that I was in a car that came out of a system that was a manufacturing plant. It was just being a buffalo, watching this thing driving by on the road. So a hyperobject is something that we have a different kind of an experience with. And there's an amazing hyperobject out there that we're living inside of right now, and it's called global warming. It's something that began, it's hard to say when it began, 10,000 years ago. It's something which is going to go on beyond us. We have no idea if what we do here will have a positive impact on it. It's something that we touch once in a while, we think. The comment was made this morning at breakfast about the Arab Spring being a climate event. Yeah, you've got to think about that one for a while. Because of droughts caused by climate in Russia, which dropped off the food supply, which led to food riots. Now, there's a lot of other factors. We humans tend to sort of think things are, this causes that. It's much more complicated than that. So these two things, hyperobjects and Anthropocene, and then the fishing being shut down at 2 and everything else, just really got my angst up. Excuse me, I've got to get used to this. And I don't expect you to read this, but I wrote this blog post this summer with 2 keywords. These 2 numbers should make the hair on the back of your neck stand up. Stand up in fear. And this goes to Peter and cognitive science. These numbers don't make the hair on the back of our neck stand up. They're too abstract. It's not the enemy that's right in front of me with a mean growl on his face. 400 parts per million in the 6th planetary extinction crisis. Well, that's pretty easy to forget about. We live in cities. We don't think about it too much. We've got zoos to go to. We don't think too much about 400 parts per million either, because the way we figure it, somebody will figure this out. We'll come up with the technology. But our premier climate scientist, just in the last couple of weeks, has come out and said, folks, this is actually worse than I thought it was. This is accelerating. Something else is going on here. And a lot of people aren't aware of the methane feedbacks that are taking place now and the sheer amount of methane that's being put into the atmosphere. Like this little volcano we've got in Southern California that is spewing methane up into the air because of a gas leak, which is a lot like the leak that took place at the Macondo leak. Except we could see that. We could see it underwater. We can't see this invisible gas that's being put into the atmosphere. And our premier life scientist, E.O. Wilson, has just come out and said, and he's just so wonderful. If you've not read Consilience, it's beautiful. He said, we've got to set aside half of Earth for life, because right now the extinction crisis is 10,000 times the normal background rate. We're killing life, and life is what we depend on. So I was pretty angry this summer. And the good news is, look at what Gensler's done. We signed up, we sent people to COP21, and we signed the Paris Pledge for Action on Climate Change. So, this is what I'm up to. Our focus will be on demand reduction. I'm going to talk to the firm. I've got 350 people coming together in 3 or 4 weeks in Las Vegas. I'm going to be talking to them about how we're going to do these first 3 things. And then it said here at the end, climate change mitigation is a great challenge of our time. I would say it is the greatest challenge of our time. It is the crisis which we should be mobilizing around as if we were mobilizing for World War II. So, here's a story I'm going to tell you about an airport I'm working on. San Francisco is taking down the T1 terminal and building a brand new terminal and 2 brand new boarding areas, about 1 million square feet. And the airport wanted to do a net zero energy airport, which is a very ambitious goal. And in fact, it's not going to be a net zero energy airport. You can't make an airport net zero energy. Not really. Not unless you don't want to have people movers and you want everybody to carry their baggage to the plane. And on and on. But nevertheless, they have very ambitious goals. And as a consequence, we have really gone hard at this to try and put something together for them. And so here I am, an architect, a designer, a tool user, trying to use software, sustainable design software, on a project. And talk about coevolution, because it's really been a search for the right technologies to do the right thing that we needed. It's not something we've done before. And in fact, we're dealing with vendors that are changing and developing new capabilities, and all the vendors bring different capabilities. And oh my God, what a mess I've got on my hands, because we've got 2 major design firms with 2 sub-design firms underneath them, with design builders, with 2 different builders, with 2 different cost managers. We got 300 people gathered together in a big room trying to design this thing in a fast track environment where we're getting ready to buy steel. So I had a plan. I thought we could do it in Revit. And I was excited. And I'm going to tell you why I was excited. The plan changed as we went along. It's messy. It's a messy process. There's a lot of people involved. Yeah, we use a lot of technology, but we still use a lot of tracing paper. We still use a lot of physical models. It's a process on the edge of chaos all the time. But this is the trick. All right, this is easy stuff. This is a diagram from Charlie Brown, Net Zero Energy. This is how you do it. You use climate as a resource. You focus on the use of the building and you work to change the use. You work to change the behavior. And then through design, smart site design, smart building design, you reduce the loads on the building. By reducing the loads on the building, you can buy smaller systems. And when you can buy smaller, smarter systems, you're saving energy, which means you're saving carbon. And although we're talking about energy, we all want lots of good, clean energy. What we don't want is dirty carbon. That's the general strategy, and whether you're doing it for a net zero energy building or any building, this is the strategy to follow. This is what we as designers should be doing. This has been forgotten about, because for the last 40, 50 years, we've been able to just throw energy at our problems. HVAC engineers, yeah, come on in, blow cold air over these people. We can put up solid glass buildings. Doesn't work that way anymore. I just had to throw this in because I love basalt columnar structures. But this is a space filling strategy, and this is the innovation that Autodesk came up with that caused me to think I could really use Revit to do this. We've been trying to use something called GBXML, which is just a pain to build a GBXML compliant model. You just almost can't represent architecture in that way. Autodesk went away from GBXML and said, we're just going to use a little cube, and we're just going to fill up this volume. That doesn't matter if the building's a little leaky or whatnot. We're just going to use a space-filling volume. It's called voxelization. And the net result is I can really build, inside of Revit, energy models that work on almost any Revit model that we build. This is a big deal, really big deal, which just now made it possible to do energy modeling. However, what's an even bigger deal is what they did with the data. All right, so here's a bunch of projects. I only submit them once. You can't read this. These are the run counts in the range of hundreds. So Autodesk is going out there and taking my one simulation run and running another 100, and those 100 runs are actually designed to leverage them down so they're not running 1,000 runs. And what they're doing is they're taking the design that I have and they're pushing it through all of its possible variations in the cloud on a supercomputer. And they're compiling a big data set, right? And then they're giving me a web interface into this data set. And I can't show you the web interface. I'm going to show you a little bit of it, what it looks like, how I recompose it. But now I've got a web interface into a data set where I can adjust the sliders to say, well, if we make this decision, this is our energy impact. If we make this decision, this is our energy impact. And we can do that live with the client because the simulations have all been pre-run. That is incredibly powerful. What it gives me is an amazing sensitivity analysis like that, right off the bat at the beginning of the project. Plug loads, number 1 problem. Lighting, number 2 problem. Schedule, number 3 problem, and on down the line. Of course, what surprised everybody, window-to-wall ratio, something we think is a big deal, not a problem. Doesn't matter what you do there. That's largely because there's just so much roof on this building. And so with all of the different kinds of configurations that we do, we now have a tool which gives us immediate insight, and in fact, it's called Insight 360. I don't mean to be, believe me, I don't mean to be promoting Autodesk products per se, but this is good. This is really good. This is great. This democratizes energy modeling. Architects can do this now. In the past, it was run a simulation, make a change. Run a simulation. What caused the change? What was the result? Now we've got 100+ simulations ran for us and a great little interface into this big data. Big, big, big move in the right direction. Thank you, Autodesk. And very quickly, we've got numbers that we can count on, and the reason we can count on them is because there have been so many simulations run that we're getting reliable averages and means from a statistics point of view. And we can make valid comparisons just with respect to lighting efficiency. So if I say I'm going to take it all the way down to 0.3 watts per square foot, that is the savings that I get. And lighting is the big problem for us on this job, and it's our one opportunity, because we're so constrained on the envelope and the systems that lighting is the key. And of course, lighting is so important to architecture, and that lighting would be the big element that we can attack, I think is a wonderful thing. I've been telling my friends about a wonderful trip I had to Spain this year. The Sagrada Familia, pictures do not do it justice. Go to Barcelona if you haven't. I see some people agree with me. And so this is what Autodesk brought to us from a lighting analysis point of view. This is the baggage area, it's down below. This is always a problem in airports. It's going to be a problem for us on this one. This is the departure floors above it. Folks, that's about 700,000 square feet. Previously, to run a lighting analysis on a floor plate that was that large, I would have set a computer off for 3 or 4 days on that. Okay? This little laptop I've got here is what I've been working on. It's off in the cloud. I'm getting these images back in about 2 hours. It takes a half an hour to get the data points loaded onto this laptop and to get it to display. Hello, Christian. Thank you for joining us. This, however, this metric is a lead option 2 metric. And what I pretty quickly became aware of was that I needed to pursue some other kinds of metrics. And this ended up pulling me out of Revit, ultimately, and heading me off in a different direction, which I wasn't anticipating. And by the way, I got a team using Revit 2015. I have to use 2016, all right? So I'm building separate models. That's all got to become more integrated. And then I go off, I got another group of people that are using Rhino, right? So I got Rhino users, I got Revit users, and now I go off into the world of SketchUp. It's getting crazier, yeah. And we did great studies. I mean, the reason I wanted to try to get it all inside of Revit was if we could do the energy analysis and the lighting analysis on the exact same model, then we can really do trade-offs on lighting and energy, which is the key. But we didn't quite have the lighting tools in Revit that we needed. And so I went off and built a SketchUp model and started looking at Saphira. And began to get, and Saphira has some opportunities also because it has energy analysis in it, and I love this Sankey flow diagram. And it gets me at these 2 metrics, which is spatial daylight autonomy, which is an annual metric, and annual sunlight exposure. And those are really good keys as to whether you're getting enough daylight and or possibly too much glare. On an annual basis, like an energy study, which is on an annual basis. So you're running daylight analysis over the course of a year against a weather data file. And again, thank God it's in the cloud. So SketchUp model, and this building is so big that just trying to part it down at times to study subparts of it is in itself a complicated task. And you can see that what we're doing, the big design thing here, and what Gensler brings to this is our retail experience. And the big thing that's changing airports, and we did this at San Francisco T2 leading the way, is we're turning them into marketplaces. And this is a big marketplace that we're building in the middle of this airport. And so we're trying to figure out how are we going to get daylight into it. And finally, that took me to SketchUp in order to get access to this specific tool, which is called Lightstanza. So I'm promoting Lightstanza at this point because it gave me what I needed coming off of this Saphira model. All right. So we're looking at how we fit this stuff into the structure. What does it look like with what's going on underneath it? And then we're able to do, again, in the cloud, simulation across the whole year, look for and find those spots where glare is a risk, and we're able to come to understand where do we have significant issues of glare and heat gain. We're able to understand that, we've got a building which is, this is the UDI is what? Uniform Daylight Indicator. We've got a building which is pretty well daylit at this point in time. If we can deal with this glare coming off of the southwest and southeast part of it, and work a little bit more at getting light up into the northern part of the mezzanine, we're going to be in pretty good shape from a daylighting point of view. So we're now getting the kind of feedback that helps us dial the design in. We've got a long ways to go in terms of integrating it all together into a smooth design process. But this is the first time that I'm aware of that we've been able to do this on a project of this size, of this scale, this early in design. So I'm pretty jazzed. The other reason we were trying to get everything coming out of the Revit model is that the other thing that the client wants us doing is full life cycle assessment accounting. And that means accounting for the environmental impacts of all of the products and the processes and the materials that are going into your building. This is a big, hairy, audacious goal. And we have connected it up to Revit. We have not, at this stage of the game on this project, we haven't succeeded because it's moving too fast at really bringing integrated life cycle assessment into the design thinking. I mean, we've got some studies going on with respect to concrete, we've got some studies going on with respect to steel, but they're fairly generic studies that we can conduct fairly early. We haven't had a specific design options because we're moving too fast that we've been able to take advantage of life cycle assessment. And you look at those pie charts and you go, well, that's just abstract, I don't know what the heck that means. You don't know what these mean until it's your project and you're working on it and you're looking at those numbers. And so my test on this was I had a little project I was designing for myself, a little cabin. And I put that cabin into Revit and I started looking at the life cycle assessment. It was like, oh my God, you see where all the impacts are. It's all the manufactured stuff. It's really simple. It's the stuff that's coming out of plants. It's the metal roofing, it's the unitized window units. You know, that's where the damage is coming from. So I'm thinking, yeah, now I understand why I need to do a straw bale house. Natural materials, simple materials. And so I leave you with this slide image because I see us all moving towards technology, but I myself, I like the idea of things made by hand. It was so wonderful being in Spain and experiencing the craftsmanship. It's so wonderful to experience materials like Port Orford cedar, which is incredibly rare. It's so wonderful to experience tools. And as an architect that's been doing digital design work for 30 years, I cannot tell you how much pleasure it gave me to make out of bamboo my own marking chisel for a left-hander. And I made it myself. And I think that's ultimately what sustainability is talking to us about. It is about a different way of looking at and participating and being in the world, which I think is ultimately good for ourselves and our souls. That's it. Let's have some discussion. How did I do on timing? Did I blow my budget real bad? 8:57? Yeah. No, I'm good. Deke's not scheduled for another 10 minutes. So, what did, of what I've said to you, did any of it resonate? Any thoughts? Come on, guys. This is a talkative crowd. Brad, we've got our runners here. Brad, did you have a question?
Yeah, can you mentioned some very specific tools and some specific problems. You also mentioned lead 2 wasn't good enough. It wasn't getting you where you jumped to lead 4. Can you talk about, not about the tools that you used, but the tools that weren't there? What weren't you able to accomplish that you needed to, other than the transitions among the tools? What were the pieces that you wanted to see but couldn't find?
Well, you said other than, but truthfully, there's another tool I want to look at next. But the biggest thing we've got to solve is this workflow problem between designers that want to work in Rhino, and I understand why they want to work in Rhino. Rhino is great at geometry manipulation. But the only performance tools they've got access to are the Ladybug Grasshopper tools, which are great tools, but they don't scale up. They take programming expertise to use them. So I've got to get past this Rhino workflow, Rhino to Revit to SketchUp workflow issue, is because I really hoped I was going to get it all in Revit, and it didn't work out. I'm in a world where I've got to be able to use multiple tools to get at the best analysis capabilities in whatever piece of software is out there, and it's evolving. That's the whole thing about it. It's changing all the time. You just got to be in the market using the most recent stuff, and that's risky and dangerous also.
So in this particular discussion, we actually have a briefing or a roundtable topic, I don't remember which, it's in your program, called the Federated Toolbox. And we can bring this discussion exactly to there. It's about taking all of these tools, and what does it take to get them to work with one another?
I would say other than that, the database that Tally is using from a life cycle assessment point of view, that just needs to get fleshed out a lot more. I mean, I think there's a lot of opportunity and power in doing a better job at linking the life cycle assessment information up with the building information models. I think that's important.
Okay.
All right, I want to go to Jack next, since he's on the left here.
Well, I observed I observed that you started out with a presumption of a building, when in fact what I want is a way to facilitate I passengers and freight to J air carriers with K runways. And that may not be a building. So why am I bothered about making the most efficient building when maybe a building's not what we really need?
You can hang on in. Yes?
Each of us, as individuals, as companies, as organizations, as governments, has dials that we can control and dials that we can influence. And there are certain things that we can do, and there are certain things that we are tasked with. So Jack, let's say that the impact on the runways is 2 orders of magnitude larger than the impact that the building has. The building needs to get built anyway, and all of this matters. The fact that there are scaling differences doesn't negate the need to do better at each individual level. The point that you're bringing up, though, is really large, and that is doing this just for buildings is nowhere near enough. And what has to happen is we can show success in different areas and continue to raise the bar for what is expected to be standard practice and move that across sectors.
That is not my point.
Okay, then I missed your point entirely.
The point is not we're going to do this for a building because we need it for other things. My point is exactly the opposite. Why do you presume a building?
Well,
You want to handle it, or?
no, go ahead. I think Christian, I mean, there's all kinds of thoughts racing through my mind on this one, believe me. There's things I'm being careful I don't want to say.
So the one way to look at it is a building is going to get built because the city of San Francisco believes that it needs it.
Yeah, that's one way.
And
other forms of stupidity.
and whether that's right or wrong, if a building is going to be built, then it should be done better. A second part of that is, should a building be built? And should we, if we don't build a building, will that, what will that affect? What will that impact? Will that make things better or worse overall? And that's a larger systems level problem, or a systems level conversation that may or may not be able to happen with the city government.
Just observe that you're putting your energy into, focusing on the tools for a better building instead of the tools for what we really should be doing, not necessarily a building.
We've got other people that want to get into this. You guys can't hog the conversation here.
A fool with a tool is still a fool.
One more. So the last statement, and then I will butt out. The last part of it is, Jack, you are absolutely correct, except that our domain is tools for design and engineering today, and that is what we are building. Should there be a domain of tools for an analysis for what you're proposing, the answer is absolutely yes. Could we be doing that? Maybe the answer is yes. If so, then the question becomes, how do we get there? And that's a conversation we can have here now.
And that's what caused the French to build the Maginot Line.
Imagine
Well,
all right, we've got,
I want to
Michael?
challenge the premise, but we don't have enough time for that. Ken, following up on, I've lost track of my train of thought after that discussion. These things fall into the category of what I would call insight that informs design. So whether it's energy analysis or the daylight analysis. And also, it's comparative analysis. It's not predictive. You're making general decisions about the design and how does it compare, how does one decision compare to another. Extremely useful, extremely powerful. To what extent have you been successful in getting that insight to inform the design? In other words, you've got your designers who like to work in Rhino. Is the feedback loop working with this insight?
It is beginning to work now. And it's taken 3.5 months of working with the team, building a level of trust over time. And we've got some trouble areas. I mean, we've got young designers that are they just want to build cool forms. And they think that intuitively they know how to do daylighting. And they don't. Peter.
So about the same time that Jack was concerned about the runways, I was kind of go. So the other there's always this idea of solving a problem the next level up, and the next level up probably really is the airplanes, which are the least efficient way of getting around. So in a way, what's cool about what you did is a sensitivity analysis.
Right.
And what you found is that you could deal with the 20% that was lighting and maybe save 30% of that. So that's cool, but the level up is that airplanes are the least efficient way to move people. I actually happen to, living in the Bay Area, know that about 1/3 of the traffic in there is from LA. We had a conversation about putting a train, which is one of the most efficient, and so the risk that I would put as a counterpoint here is that sometimes we pat ourselves on the back for we're green now, and yet what we're really doing is, we put a couple LED lights in, but the much bigger priority. In a way, kind of echoing that, and really suggesting these sensitivity tools need to be at a like at a state level, at a policy level, that we really need to move them up a little bit higher.
While the mic's being handed off, one of the big things we're trying to do here is if we can lower the energy use on these buildings and make a flip over to heating and cooling them with radiant energy instead of blowing air on people, then we have the potential to have a huge impact on the city of San Francisco by putting them into a situation where they don't have to build a new central chiller plant. That's the big thing we're trying to accomplish. Yeah, so there is a larger level of systems thinking that is taking place. But it's hard. I mean, it's hard to get it to the building level, much less multi-building campus, citywide sorts of things. Christian.
In your defense, Ken, you work for a company that builds buildings and that doesn't reinvent industries. So I think you work at the scope where your company requires you to work, and maybe sometimes slightly bigger scope, but I don't think that you can afford to reinvent the industry. I think a couple of years ago, the theme of COFUS was about wide thinking or something like that, or thinking wider. I forgot exactly how it was framed. But I noted two things. One is we should always get back to why we do things. Why this building? And I think much of the discussion here is about that. It's like, okay, but maybe the building is not the answer to the question. We decided we want to build a building, but why do we want it? And I think in the why question, and then sustainability, there is also, do we put the sustainability before the question about the building, what we are doing, or do we decide what we are doing and do we put the question of sustainability behind that? And the other is indeed, how broad are we thinking? Just when I walked in, and I'm sorry I missed the beginning of your presentation, you said, yeah, those models are very complex and some people are looking at parts of it, meaning they will sub-optimize. If you're looking to regarding the building, if you look at the building, you're sub-optimizing regarding the airport. If you look at the airport, you're sub-optimizing regarding the transportation problem. And if you're looking at the transportation problem, you're probably sub-optimizing regarding society, the society we are and whether we need to travel or not. So those are like, good topics for next year or something like that.
Yep, Stephen?
So Ken, just wondered, when you're working on something like lighting solutions, at what point do you have any visibility into when you're looking at components, to actually choosing components for that? Obviously, you're going to look at energy efficiency and all of those things, but do you have any visibility into how those products are sourced and manufactured from a sustainability, environmental performance standpoint, and anything that tools can help you with on that?
We do, and that is the purpose of Tally. That is, Tally, I'm sorry, is the life cycle assessment tool that runs inside of Revit, that was built by Kieran Timberlake with Autodesk's help, and it uses the Gabi database, and that's what we need more data.
That's what I was looking
And we
for.
need to hook them up to the models quicker. All right, I need to move on. This is, am I okay to move? No, one more from John.
You know, I'm kind of in Ken's defense here. You know, when I was listening to him, and this is kind of the message I think Brad was looking for to go out to the software community. I'm responsible for this kit of parts that Ken uses at Gensler, and I'm kind of from the IT perspective. And what I'm seeing is I have great ability to view it across a global spectrum of what's actually transpiring out there. And when I was listening to him, one of the things he was saying is, I use this piece of software, and then I use this piece of software, and then I had to move to this piece of software. What he really wasn't looking for was software. What he was looking for were capabilities. That's what he was looking for. So, you know, I think as a software provider, everybody wants to create the ultimate environment, right? You can do everything that you need to do inside of Revit. I feel like Joey Zuzu with He's Lying across the bottom of the screen. But when really all we want is certain capabilities from Revit. We want certain capabilities from SketchUp. We want, so that modularity to be able to bring these apps in, right? That a piece of software offers this particular capability as almost like an app that can be brought into your environment and run. So they're really looking for those capabilities, not necessarily the software. So that's kind of in defense of what Ken was talking about. But it puts emphasis on the tools that he's trying to use to do his job better, right? He wants to build a more responsible building, or a more responsible. It's his task, it's what he's been given, it's what he gets paid to do. He wants to do the best he can do at it. So capabilities are really what's needed, not pieces of software.